Hey, Yasmin, we're just waiting for like a couple more people to filter in and we're just getting stuff set up. So you can hang here or filter somewhere else and come back if you want. It's up to you.
Damn, you look like spiffy, bro. Look how I look.
You look fine. What are you talking about? You got the glasses, you got the shirt. I think it's my background. That's
Yeah,
why.
my background's like my sister's room, so.
Yeah, happy birthday.
All right. Wait, we have to share the thingy. Do you have the thingy?
Yeah, we gotta screen share the presentation.
Yeah.
I
Can
was
you
about
send
to
it to
text
me?
you. Like, I have my notes up on my computer.
Wait,
So,
did you send it to me?
oh, it's the slide that we submitted to. Yeah.
Might you see it on that?
It's in Outlook, or not Outlook. PowerPoint. Your school PowerPoint. Look, I'll show you just for example.
Is it the one I sent, or was it the one you titled final version?
Final version. Yeah.
Got it. Okay. Let me close.
Yeah, because I got my notes up on here and I could read it from my phone if that's better. But
I need to hide something. All right, good.
What?
Huh? What?
What? Okay.
Okay. Few. How do you fucking put it? I mean, the window I selected is invalid. Give me a second. I'm trying to figure out how to share.
Sure.
Can you see it?
Yeah. Perfect. Yes.
So I'm just gonna be
We're
like,
freaking scientists. Wait, okay.
I'm gonna keep it
simple. Hey, Yasmin.
simple. I'm gonna be like, we were tasked with creating a sustainable alternative to combating the whole issue of climate change.
Yasmin is getting the inside scoop on this process.
Huh? Oh, I know she is. It's okay. So we developed an affordable solar-powered mobile device charging system. I don't know. I don't think I should go over the introduction. They can read.
No. Go. Well, I mean, in your own words. But...
Okay. Okay. I guess I just started with that. Be like, climate change is processing. I would be like, how climate change is messing us up. We are coming up with solutions and increasing the awareness of global climate change, and then some questions we discussed before tackling this major issue was the strategies on how to combat this climate change, and also the importance of spreading awareness.
Hey, Yasmin, do you want to hear us practice our presentation? Do you want to be our little beta tester?
She already listened. And how to make practical while still being
my window. I'm gonna stop interrupting. Go ahead.
Okay. Okay. Some of the methods that we focused on was just researching background information about the green technology system and overall looking at the system design, and difference in designs, as we had a wind turbine system as an option, and also we had the photovoltaic system as an option as well. And we troubleshooted trying to see which one would be more beneficial to our systems and what would be our target goal, while again going back to it being cost effective. And we found that the wind turbine system would be dramatically more expensive than a solar powered station. And so we decided with the latter, and we chose a solar powered charging station. Oop.
So I'd like to begin the second part of this presentation. Okay, I need to quickly say there is a squirrel outside my window and he's got this hole. I'm looking at my driveway. He's got like a little hidey hole that he's clearly built. Like he's like scooped out a chunk of our lawn. He's got like nuts in there. He's pulling them out and eating them. All right, okay.
My sister has a mini fridge.
Really? Okay. Back to the presentation.
I'm gonna get water. Do your thing.
It's just let's run. Okay. So I'd like to begin the second part of this presentation by explaining what makes our system competitive. When we landed on a photovoltaic system for charging, we did research into existing systems like the wind turbine model that we looked into. But when we landed on photovoltaics, we kind of wanted to establish like a jumping off point. So we did additional research into existing solar powered charging systems, ones that are compatible with mobile devices, stuff, things like that. And the only systems out there that we could find were over $1,000 at minimum, typically in the $1,300 to $2,300 range. And if they included seating elements for users, which was initially included in our design, the price spiked up even further. So what makes our system competitive is that it does what other systems out there do for a fraction of the price, only $1,000. And it's innovative in the way that it demonstrates how accessible green technology systems can be and how they can be modulated as needed. This was an important dimension of our project because we didn't just want to develop green technology systems. We wanted to develop a system that is widely accessible, one that can be used across the greater Houston area, and one that demonstrates to the city how beneficial photovoltaic systems can be. If you've been keeping up with Houston's sustainability practices in recent years, you might know that the city of Houston proudly boasts an energy profile that centers renewable energy, but this refers specifically to commercial buildings in the heart of the city. Buildings in other sectors, especially those in the greater Houston area, still contribute to an energy profile centering non-renewable sources. Houston also remains to be the biggest producer of crude oil and natural gas in the United States. The city has seen an increase of severe weather events, including floods, hurricanes, tropical storms, and ice storms within the last decade. These events have collectively resulted in hundreds of deaths and billions of dollars in property damage. During an emergency flash flood in 2019, hundreds of people in the city of Houston were left without reliable access to power. By implementing an affordable and reliable power system on the University of Houston downtown campus, we hope not only to enhance our own campus and our city, but to demonstrate the efficacy of green technology systems as a whole. So on to like the technical side of our project. You can see the main electrical system demonstrated in figure D. So it's a solar panel, a battery, a charge controller, and an inverter, basically. So solar panels convert the energy of photons or light particles into electricity. This process is called the photovoltaic effect. When a photon hits a photovoltaic system, it's transferred from the energy is transferred from the photon to the local electrons in the material. These excited electrons are what produces an electric current. The solar cells within solar panels produce direct current energy, which the inverter then converts into alternating current and electricity. This essentially allows the electricity produced in our system to move freely until it's adapted back into direct current energy for storage in our deep cycle battery or for use in mobile devices. In our system, a battery was essential. Solar systems produce electricity variably depending on the weather, but we wanted to supply a reliable source of energy. We chose a deep cycle battery, which is a lead acid battery that is designed to be regularly, deeply discharged, constantly expending most of its energy capacity. And this gives the system a lot of flexibility. Because we used a battery, we also had to use a charge controller. Our charge controller is what regulates the flow of electricity from our photovoltaic generator into our battery. It helps to regulate overcharging or discharging of the battery. Even though we used a deep cycle battery though, it generally is not good practice to frequently deeply discharge a battery because that tends to shorten the lifetime of the battery. So the schematics pictured, like I said in figure D, no, the other schematics pictured, C and E. These are from the early stages of our project where we initially planned for our system to be a stationary system near benches for convenience. But upon deliberation with facilities management, we decided it would be more effective for our system to be mobilized. So we're currently working on this transition. We're basically just going to move the main components of the system onto a cart so that I can, so that it's mobile, it can go around the campus. But we have tested our system. It is fully effective. It charges phones just fine when it's in the sun and if it's been charged recently when it's not. And it's going to be up and running this summer. So this project was an invaluable experience for me and Irvin. We learned a variety of soft skills like collaboration, teamwork, and interpersonal communication. We also learned a myriad of hard skills like research and verification, mathematics, engineering, presentation, technical writing, and project management. This is definitely an experience that has enriched our personal, academic, and professional capabilities. And to wrap up this presentation, I would like to thank our incredibly helpful and supportive mentors, Mr. Juan Martinez, the Sustainability Coordinator at the Center for Urban Agriculture and Sustainability, or the CUAS, Dr. Lisa Morano, the Director of the CUAS, and Dr. Vasilios Juanas, the Department Chairman of the Computer Science and Engineering Technology Department. I now open the floor to any questions you might have.
So hello, whoever joined in late. Apologize. I went to run one through. So just to catch y'all up, let me restart it. That way you guys understand what we're talking about.
Well, if you happen to have any questions in the meantime, y'all, go ahead.
I mean, feel free if you guys have a question right now. And if you're not, then I'll just restart the presentation. And I get a hands up at least to know like if you guys are ready. That way I can start. Thank you. Okay, so we're targeting a main issue that's ongoing even now, and it will continue affecting us in the future years. So it's combating climate change, and we were tasked with figuring out a solution to this major issue relating to climate change. And so our project was trying to figure out what would be the best way to do so. And so we were tasked with developing, again, something that's also affordable, practical, and being able to spread awareness as well, because it's one thing for us to understand the climate issue, but also trying to inform the public about it. And so again, climate change is predicted to lead to increased global temperatures and and really disrupt local weather patterns that we have seen in the latter years that's happening. Hurricanes becoming a lot more aggressive, natural disasters happening at a much more frequent rate than it was beforehand. And again, it all happens with minor changes being done like this. And so one of the things that we discussed and we focused on was just targeting, like making sure we have some kind of strategy to how to combat this. And again, we had for this project, we had a limited amount of money that we could use in order, again, to make it cost effective as well. And so, for many designs, many ideas that we came up with, we decided to use a solar power charging station. And even before deciding it was a solar power charging station, we had to also think about other alternatives as well. We have wind turbine systems as well. And again, picturing the fact that it was downtown Houston, major buildings, skyscrapers, it kind of really blocked and it kind of, made wind turbines not as effective as they would, out in the open. And even then a small wind turbine system would cost a lot more than a PV panel. And so that was our design, and these are just some sketches that we decided to use. So this is going to be the rough sketch for the wind turbine system. Again, simple power storage and just connects to the cell phone. But we ended up realizing, again, with us trying to make it cost effective, that would be a big issue based on the fact that just the system itself will cost more, and we would have to solder some wiring as well. And again, there was many alternatives, and the most cost effective was, again, designing a solar charging station. Yeah, so going on to the next slide.
So I'd like to begin the second part of this presentation by explaining what makes our system competitive. When we landed on a photovoltaic system, we did some research into existing systems that are already out there. Oh, by the way, I want to add, my Wi-Fi is kind of bad, so if I cut out at any time, just let me know.
Yes.
But the only similar systems out there are over $1,000 at the minimum, typically in the $1,300 to $2,300 range. And if they include seating elements like benches or chairs for users, which was initially included in our original design, this price spiked even higher. What makes our system competitive is that it does what systems out there do for a fraction of the price, only $1,000. It's innovative in the way that it demonstrates how accessible green technology systems can be and how they can be modulated as needed. This was an important dimension of our project because we didn't just want to develop a green technology system. We wanted to develop a system that is widely accessible, one that can be used across the greater Houston area, and one that demonstrates to the city how beneficial photovoltaic systems can be. If you've been keeping up with Houston's sustainability practices in recent years, you might know that the city of Houston proudly boasts an energy profile that centers renewable energy. However, this refers to commercial buildings in the heart of the city. Buildings in other sectors, especially those in the greater Houston area, still contribute to an energy profile centering non-renewable sources. Houston also remains to be the biggest producer of crude oil and natural gas in the United States. The city has seen an increase of severe weather events as well, including floods, hurricanes, tropical storms, and ice storms within the last decade. These events have collectively resulted in hundreds of deaths and billions of dollars in property damage. During an emergency flash flood in 2019, hundreds of people in the city of Houston were left without reliable access to power. By implementing an affordable and reliable power system on the University of Houston downtown campus, we hope to not only enhance our own campus and our city, but to demonstrate the efficacy of green technology systems as a whole. So on to the more technical aspects of our project. If you look to the schematics in figure D, you'll see the basic components of our project, which is a solar panel, an inverter, a charge controller, and a battery. So solar panels convert the energy of photons or light particles into electricity. This process is called the photovoltaic effect, hence photovoltaic system. When a photon hits a photovoltaic panel, it's transferred, or energy is transferred from the photon to the local electrons in the material. These excited electrons are what produces an electric current. The solar cells within solar panels produce direct current energy, which the inverter then converts into alternating current energy. This essentially allows the electricity produced in our system to move freely in the system until it's adapted back into direct current energy for storage in our deep cycle battery or for use in attached mobile devices, so to charge your phone. In our system, a battery was essential. Solar systems produce electricity variably depending on the weather, but we wanted to supply a reliable source of energy. We chose a deep cycle battery, which is a lead acid battery designed to be regularly deeply discharged, constantly expending most of its energy capacity. This gives the system a lot of flexibility. And because we used a battery, we also had to use a charge controller. Our charge controller is what regulates the flow of electricity from our photovoltaic components into our battery. It helps to regulate overcharging or discharging of the battery. Because even though we used a deep cycle battery, it's not good practice to frequently deeply discharge a battery because that shortens the lifetime of the battery. The schematics pictured in figures C and E are from the early stages of our project where we initially planned for our system to be a stationary system near benches for convenience. But upon deliberation with facilities management, we decided it would be more effective for our system to be mobile. While we are currently working on this transition, we have tested our system and it is fully effective, and it will be up and running. The mobile version will be up and running on campus this summer. This project was an invaluable experience for me and Irvin. We learned a variety of soft skills like collaboration, teamwork, and interpersonal communication, but we also learned a myriad of hard skills like research and verification, mathematics, engineering, presentation, technical writing, and project management. This is definitely an experience that has enriched our personal, academic, and professional capabilities. To wrap up this presentation, I would like to thank our incredibly helpful and supportive mentors, Mr. Juan Martinez, the Sustainability Coordinator at the Center for Urban Agriculture and Sustainability, or the CUAS, Dr. Lisa Morano, the Director of the CUAS, and Dr. Vasilios Joannis, the Department Chairman of the Computer Science and Engineering Technology Department. I now open the floor to any questions you might have. So please ask away.
Hi, I have a quick question.
Sure.
Can you elaborate on the part that you were saying to try to make this as a mobile charger?
Yeah, so I mean, if you look at figure E, you can kind of see that the basic design of our project was supposed to include a wall mount on like a pole near some seating, so that people could like sit on the chairs and just have their phone on the charging stand right behind them, charge their phone, and so that's really convenient. But to better serve like the campus, we decided it would be better if the system was mobile. So right now we're basically just it's not a big change. We're just moving the components onto a cart so that I can be like wheeled around, so people can see the cart, pull it over to them, charge their device, take it wherever, or
Yeah, and hopefully, like one of the biggest keys that we're trying by making it mobile is being able to use it for school events. They tend to be held like in the stock deck, like open areas, like as you can see there in the image. And so by having that mobile charging station, we could move it there. And again, going back to that whole issue of just making a good appearance of like green energy for the public. That's the best way to do it, being done in action rather than having it there for people to admire from a distance. Yeah.
Hi.
Yep.
Oh, sorry.
Go ahead.
Go for it.
I'm done.
Hi, Riley. Hi, Irvin. I'm sorry. I came in a little bit late, but did you have like a timeline for when this would be like put in to our campus, or is it just like kind of in like the talks right now?
So just an update on that. The majority, like pretty much the whole system is done. It's been built, everything's set, all it is just us literally pulling it on something that's mobile. Like it's already made, the whole system's there. We have a solar panel attached to it. Everything's, good to go.
I'd love to add on this though. We started this project in fall of, what is it? I think 2021. Yeah, I think 2021. And it's currently coming up to the summer of 2022. So there were a few things that, we had like hiccups here and there with funding or not being able to source materials, for various reasons. And there's a lot of like administrative stuff that goes on behind the scenes when doing a project like this, because we have to, there's like permitting, talks with facilities, talks with, marketing at UH because of the design of our mobile or the wall mount. So our timeline definitely took some hits, but like Irvin said, we've completely finished like the main parts of the project. So the only step left to do is to transfer everything onto the cart, make sure it's secure and all that's good, it's safe. And then it will be on campus ready for everyone to use, and that's, like I said, that's going to happen in this summer of this year, so upcoming summer.
So will those carts, will they just have like phone chargers, or will they also have like little outlets that you can maybe like plug a?
So
Or-
doing the calculations and stuff, it would only be sufficient enough for phones so they can charge efficiently. Like there's not gonna be like a fast charger either. It's gonna be, a regular kind of like an outlet type of deal.
Mhm.
But given the fact that how big the solar panel is and the battery that we have, we're unable to supply that much of a like larger power output. But
Sure.
given if we were to upgrade it, again, this is something that's on a smaller scale. That way, if it catches wind, the university likes it, the students like it. Hopefully, like you said, we should be able to get more funding and be able to maybe even get a bigger solar panel and be able to use it for bigger things rather than just phone chargers.
Yeah.
So, and I'd love to add on that too. We would love to look into that in the future. Having different devices that it can attach to it, or having outlets or something like that. That would be an amazing extension of this project. But when we started out, our main goal was just like, can we charge a couple phones? It's like kind of like dipping our foot in the water, because like I said, there are existing systems like this out there that it's like there'll be some benches, there'll be like a little stand where you can charge your phone, and there's a solar panel. That was a terrible little but there are existing systems like that out there, but these systems tend to be incredibly expensive, very inaccessible. Often it's difficult even to get in contact with the companies that produce these. Like I looked into a couple models that, it wasn't even like an official product that exists on the market. It's like a special project that was the result of some company working with some company on who knows what. So the main goal of this project was just, can we do that, but cheaper, more accessible? So that's why we have what we have now. But in the future, we would love to expand and do something like that, especially if it gets a lot of traction. Yeah.
Yeah, I would definitely take advantage of that, because I can't tell you how many times I'm like, oh shoot, my laptop's about to die. I have, it's on the off time when I don't have class, and I'm like trying to find a seat where there's a charger nearby. So yeah, that would definitely be like awesome.
Yeah, and another application that can be used as well, since it has a battery in there, you can be charging it. Like you said, you want to use it as well. I'm trying to find like a mobile place to do it, while you're on campus. Since it's mobile, we could keep it out, let it charge throughout the day. And again, it has a battery, so it's going to store powerage. And then whenever it's needed around campus, it can be pulled from wherever it's stored, or, charging energy, bring it inside and have people charge their cellular devices, again, their laptops, and again, make it more, efficient for students as well. And, again, increase the awareness on, green energy on campus. Yeah, any further questions?
Yeah, and I'm sorry. I'm sorry.
No, it's okay. Go ahead, Dr.
Let me jump
Parker.
in and then you come back around. So I'm sorry, I missed the first part, but I'll stay to hear it again. So did you test how much current or watts power you're drawing down? I missed that. You might have talked about it. I'm not sure.
So we didn't talk about it, but that's something we did measure. And as for the wattage, it wasn't barely kind of bare, like kind of limit where it can charge again, since it's such a small scale and it doesn't produce as much power. We were only able to be sufficient enough for phones. So again, with the conversion from AC to DC, and with that conversion rate, we had enough amperes to charge phones. But nothing more, but maybe something else that could be it might be less power could be used.
Yeah, and how big was your solar panel? I'm just looking at it. Did you use 3 of them? I'm looking at the picture.
So we only used one. And you might be looking at picture C.
Yes.
So that is actually a schematic indicating the brain of our system. So that's not actually solar panels.
Gotcha.
That's actually indicating the battery, the charge controller, and the inverter. That would be in literally a little brain away from the charging component.
Got it.
And I also wanted to add on the question you had before. So there was a lot of math that went into this project. So we kind of already knew how much voltage this system was going to produce before we even constructed it. But I think it was the charge controller that actually it had like a little it like lit up, it would tell us like how much was being produced. So that's how we could confirm it while we were, you know, putting all the parts together.
Right. Yeah.
Yes.
Well, of course, you do the schematic and math
Oh yeah.
associated
Yeah.
with it. Okay.
'cause,
I'm sorry, Emily,
no,
you
you're fine.
next.
Yeah, no worries. So I guess it's more like personal question. Like what made y'all like say, okay, yes, this is what we want to do, like to investigate?
Okay, so that's a really good question. And so again, we're part of the Sustained Scholars Program, which is again with the urban agriculture, and you know they were the ones who gave us a task. They were like, hey, find something that you can do sustainable, but also here's a budget limit, right? And so our issue was trying to figure out what's something that we can do. Again, we were all very, you know, enthusiastic about it, and like we were all looking about like, you know, maybe a bicycle that can charge, you know, a battery, you know. We were like really thinking ahead, and one of the issues again was the budget. And so all these ideas are really good. You know, some of them they were like, oh, we can make recyclable, or like have like some bin that can recycle, you know, masks. It was during the peak of the pandemic as well. So it was, you know, 2021. So it was like fall 2021. So that was still an issue. So it was like a lot of people are throwing away masks and stuff. So we're trying to find a way to maybe combat that as well. Because again, that also contributes to the pollution being done. And again, pollution that will also contribute to the climate change. And you guys have a pretty rough idea of how it works. But again, so that was the biggest issue, just trying to figure out what we can do. And again, I found myself, sometimes I would go outside to go eat lunch or something, and there's no outlet to charge your phone. Sometimes I'm watching a little video while I'm eating. But again, there's nothing for me to, that was the issue, how to connect it outside. And so that's when we came up with the idea of having a charging station outside. And again, that's what we have a picture right there, that eating area. And so that was like kind of like the vision that we had. And again, like Riley said, before we even constructed anything, we already had the components already, you know, planned out before. Because again, the real testing wasn't even real, like actual mathematical testing. It was just to see if it worked, because all the math had already been done previously. All we did was just connect the components. Again, some components didn't fully fit, so we had to make some adjustments, cut some of the wires. And, you know, and that was also a technical learning aspect where I learned how to, you know, work with wiring, something I'm not too familiar with. So that was a learning curve for me. But at the same time, we were able to produce something that was, you know, a vision at first, and now through action, it became something.
Yeah, this was more of Urban's brainchild, to be honest. But I was like on board from the jump, because we're both, I think Urban, you're majoring in sustainability or minoring in sustainability too, aren't you? Yeah, so we're both minoring in sustainability. We were both sustained scholars. We're both very interested in sustainability principles and technology. We're interested in sustainability from every single angle. So what Urban explained how he came up with this, but when he suggested it, I was on board because it sounded ambitious. It's, you know, something that is a present need on campus and for the city of Houston as a whole. So yeah.
And it's neat because it's potentially something that we could see and encounter like on a daily basis as students, which is really cool.
Yeah, and that was pretty much the basis as well as to why making it cost affordable and something that's, you know, done at the university. Because again, in the tasks that we were issued, you know, telling us like, hey, think of something that combat, you know, something that's sustainable. They give us the option to do it, you know, locally on our campus or, you know, off campus. But my idea was to do it locally on campus, because that's where the ideas are made. That's where, you know, people do things, they see things, and that's where the community's at. And so, and again, when it comes down to sustainability things, whenever you see wind turbines, you have to go really far out in Texas, you know. Solar panels, when's the last time you see a solar panel? You only see them locally, like little cameras that they have at Walmart, you know, but you don't really interact with it and you really have no idea how to use it. And so again, by making this also affordable, it gives an option for people who also were interested in learning how to make it. They can see that it can be done under $1,000. Yeah.
Awesome. Very cool.
Thank y'all for your questions. We are open to taking any more questions. Okay.
And again,
well,
I will be, sorry to interrupt you real quick, but just to clarify, in case you guys want information about the schematics, and you just a quick, like, you know, run down the parts that we used. We are more than like willing to share it with you guys. Again, the whole process of this project was to raise awareness on the, issue on climate change and how to, make your own solar panels. So I'll be sharing my school email. You can contact me through there in case you guys want more information about it. But other than that, take it away, Riley.
Oh, I was just gonna ask if anyone has any more questions. I was actually gonna say, like, put it in the chat. Like, do you want us to restart? You want to ask a question? Like, whatever y'all want.
I think I have it. I'm going to say a goodbye, but I really thank you for recording your session. Very nice.
Thank you, guys.
Can you hear me?
Yes.
So this is a solar powered charging station,
Yes.
and it's for, so basically how does it just charges, and just like the charging center,
What was that?
just like the charging stations that we have around campus
Yeah.
in the science and tech and the business building,
Uh,
just solar power.
Kinda. I mean, it depends on which ones you're referring to, because I know there's some in the academic building where it's like you put in a code and it opens up and you put your phone in. Our system's not that advanced. Our system is mainly, there's a mount section that's basically just like sheet metal. And then there's, okay, cool. There's 2 charging ports coming out, and you can just go up to the station. And because it's going to be a mobile system, you can just like wheel it up to you, put your phone on it, charge for however long you need, take your phone off, push it away, or whatever you want. So it's similar in some ways, similar, not similar in other ways. And especially it's solar powered, so it's different in that way.
Okay.
Yeah, because that you're bringing that up, that is something that kind of was an inspiration to what I was talking about. But again, that issue with that is that it's not mobile. And again, since how we're passionate about sustainability, it's not sustainable as well, because it's pulling power from the grid. And right now, currently, a good majority of it will be soon, hopefully. But for now, we can only do so much for ourselves locally, and so that's why we decided to do what we did.
And Karina asks, how would y'all feel about offering portable chargers instead of regular outlets, and attaching portable chargers to something so people can't misplace them or lose them? I think there's actually been a miscommunication, because earlier we were saying we would like to expand into maybe offering outlets or something like that, but our system currently does have chargers on it, and it is it's totally fine. It's totally fine. I know some of y'all came in the latter end of our little spiel here, so yeah, you're totally good. I think we're maybe ready for another round.
Okay, so there's no further questions. We're gonna kind of restart, that way everybody can be caught up on what we're talking about. Okay, so again, Andre, do you mind muting yourself for a bit? Sorry, I just hear something.
Sorry.
Yeah, no, you're fine. So again, our project was combating climate change, right? Big issue, something that's not very easy to do. And again, what we did was we were tasked with finding a solution that's sustainable to this emergent issue of climate change. Some of the prominent questions that we asked ourselves is like, how do we do this, right? And apart from that, they also gave us some kind of a limiting factor as well, which was the budget. They gave us only $1,000 to come up with something that's sustainable and combats climate change. And so one of the biggest things for us, like one of our questions was like, how do we do this? What's going to be our approach to this? And again, the main key of this is to also spread awareness, because there's no point in us, making, these issues known, or, combating these issues without making any kind of awareness. Because again, we ourselves, just me and Riley can't, just make a huge change for everything. It has to impact the community. And again, it also had to be cost effective, because we had a budget of $1,000. And so some of the methods that we did beforehand was, we did some extensive research on on things because there's already a bunch of projects already in place, bunch of solar panels, different things that had already been in place. And so something we had to do was try to make it different, but at the same time build upon what they've already done. And so one of the things that we focused on was the system designs and and troubleshooting any kind of errors that might have had in those designs, and as well as thinking of alternative solutions. So first, what we thought about was using a wind turbine system. But the issue with the wind turbine system, again, we were planning on doing this locally. So on our campus, UHD, and as many of you guys know, it's downtown. So there's tall buildings, huge buildings blocking, most wind. And so even it wouldn't be practical to use a wind turbine for the most part. And also, again, trying to be cost effective was the biggest thing. Wind turbine systems are not that cheap. And even the cheap ones themselves don't produce enough power that we would be needing to charge. Because again, our issue was that we wanted to create a mobile charging system. Well, not a mobile one, but just a charging system in itself that could charge multiple devices at once, not just one device. And so given that factor, the wind turbine system was not going to do its justice. And so the other alternative was solar panel. And, luckily we have a whole south deck, if you guys are familiar with, that's, pretty much facing the sun for the most part. And so that would be the most ideal thing to do. And so that's why we constructed this kind of rough sketches right here at the bottom, as you can see. And so again, this is a rough sketch, very rough. This is in the early stages of the development of this project, but this is what we thought about. And again, that the solar panel was going to be the most cost effective and, a much simpler design, but sometimes simpler is better.
So Irvin touched on what makes our system competitive, but I would like to emphasize just a couple things. To kind of sum up the whole windmill design, that would be just an incredibly ambitious endeavor that would take a lot more sourcing on our part to try and find these niche materials for a system, because windmills have to inherently be pretty tall, or high in the air. Their blades generally have to be pretty big. So we were looking at a lot of issues. Soldering, which is, they're loud. There's also an effect, I forget what it's called because I did the research like a year ago, but there's an effect where it can cause a light, it's called light flicker. It causes a flickering light in the afternoon that can be at least aggravating, at most dangerous for people who fall in that shadow of flickering light. It's literally exactly as it sounds. Like for a few hours, you just lights on and off like a strobing effect. And that's, not ideal. So with all of that, we were just like, nah, windmill is out. But yeah, Karina, you're on it. So we landed on a photovoltaic system. Obviously, solar power it's very topical, very relevant, and not a lot, but a good part of our green technology profile in Texas, I'll say that, is from solar energy. So we did some research into existing systems because we had already kind of decided we wanted to do a green tech powered mobile device charging station. So we looked into other systems that are already out there. And the only systems that we could find were over $1,000 at the minimum. So typically $1,300 to $2,300. And if they included seating, that price spiked way higher. It could even be up to like $10,000. And some of these systems weren't even commercially available. They would be like some special project that was funded by some company for some brand promotion, very difficult to get in contact with, inaccessible, unaffordable. And what makes our system competitive is it does what those systems do for a fraction of the price, only $1,000. And it also demonstrates how accessible and viable green technology systems can be, and how they can be changed and modulated as needed, because we went through many different design iterations. So this was a very important dimension of our project because we didn't want to just develop a green technology system. We wanted to develop a system that is widely accessible, one that can be used across the greater Houston area, and one that demonstrates to the city just how beneficial photovoltaic systems can be. If you've been keeping up with Houston's sustainability practices in recent years, you might know that the city of Houston proudly boasts an energy profile that centers renewable energy, but this refers to commercial buildings in the heart of the city, the very center of the city. Buildings in other sectors, especially those in the greater Houston area, because we all know Houston is not just Houston, you know, it's huge. So a lot of these other buildings still contribute to an energy profile that centers non-renewable sources. Houston also remains to be the biggest producer of crude oil and natural gas in the United States. The city has seen an increase of severe weather events, including floods, hurricanes, tropical storms, and ice storms within the last decade. And that's relevant because, as Irvin said, I think maybe 5-10 minutes ago, climate change, one of the symptoms of climate change is seeing a dramatic increase of severe and pervasive weather events. And these events in Houston within the last decade have contributed to hundreds of deaths and billions of dollars in property damage. During an emergency flash flood in 2019, hundreds of people in the city of Houston were left without reliable access to power. So by implementing an affordable and reliable green tech system on the University of Houston downtown campus, we hope not only to enhance our own campus and our city, but to demonstrate the viability of green technology systems as a whole. So on to the more technical components of our project. If you look at schematic D, you'll see like the brain of our project. That's our solar panel, which is connected to our battery, a charge controller, and an inverter. Solar panels convert the energy of photons or light particles into electricity. This process is called the photovoltaic effect, hence the name photovoltaic system. When a photon hits a photovoltaic panel, it is the energy from that photon is transferred into the local electrons in the material. These excited electrons are what produce an electric current. The solar cells within solar panels produce direct current energy, which the inverter then converts into alternating current electricity. This essentially allows the energy in our system to move about freely until it's adapted back into direct current energy for storage in our deep cycle battery or for use in attached mobile devices, or so when you want to charge your phone. In our system, a battery was essential. Solar systems produce electricity variably depending on the weather, but we wanted to supply a reliable source of energy. I mean, obviously we expect we hope that there'll be a lot of traffic in this system, lots of people constantly charging their mobile devices. So that would put strain on a normal battery because it's going to be constantly discharge, recharge, discharge, you know. So we chose a deep cycle battery, which is a lead acid battery designed to be regularly, deeply discharged, like I just explained. And this gives the system a lot of flexibility and it just makes it more reliable. Because we used a battery, we also had to use a charge controller. Our charge controller is what regulates the flow of electricity from our photovoltaic components into our battery. It helps to regulate overcharging or discharge or, discharging too deeply the battery. Even though we used a deep cycle battery, it's not good practice to frequently deeply discharge a battery because this tends to shorten the lifespan of the battery. The schematics pictured in figures C and E are from the early stages of our project, where we initially planned for our system to be stationary near benches for convenience. But upon deliberation with facilities management, we decided it would be more effective for our system to be mobile. So we're currently working on this transition, just getting all the components onto a cart so that it can be wheeled around so that it's mobile. But we have tested our system. It's fully effective. It completely works. So the mobile charging station will be up and running on campus this summer. This project was an invaluable experience for me and my partner, Irvin. We learned a variety of soft skills like collaboration, teamwork, and interpersonal communication, but we also learned a myriad of hard skills like research and verification, mathematics, engineering, presentation, technical writing, and project management. This is definitely an experience that has enriched our personal, academic, and professional capabilities. To wrap up this presentation, I'd like to thank our incredibly helpful and supportive mentors, Mr. Juan Martinez, the Sustainability Coordinator at the Center for Urban Agriculture and Sustainability, or the CUAS, Dr. Lisa Morano, the Director of the CUAS, and Dr. Vasilios Juanis, the Department Chairman of the Computer Science and Engineering Technology Department. I now open the floor to any questions you guys might have.
Okay, before y'all start, Andrea, they have a question about how safe this is in terms of the weather. So this doesn't affect the weather directly, to answer your question. So again, this is like a solar panel. It doesn't, interact with the weather at all. In the case of, where it does, it's actually just leave it out. Again, since we're going to move into more of a mobile aspect of this, again, we see a storm coming up. We're not going to leave it outside either. We just get inside. And again, it doesn't directly affect the weather. That would be a cool thing to maybe do, but it doesn't affect the weather at all.
Okay.
Or unless your question was, the structure is differently, but in regards to it, like directly affecting weather, it has no effect on it at all.
I saw another question in the chat that I thought was super interesting. Have you guys thought about using the solar energy to power fans in outdoor seating areas? This could be great in the new gym UHD is building so students can jog, run stairs outdoors with airflow. I think that is a fantastic idea. Please send that idea to the higher ups. We would love to get involved with that.
Not interrupt with that, but
go for
the
it.
current scholars who are, the new period of scholars, they're actually working on that. And they're using some of our schematics to build off of what they're doing. So that's also coming, not our direct project, but somebody else.
I didn't even know it.
So,
but that's amazing. And just to be a little bit nerdy for a second. So one aspect of sustainability thinks about, related to climate science, thinks about adaptive and mitigative strategies for addressing climate change. So if you look, I'll promise I'll show you where I'm going with this in a second, but our system does a little bit of both because we're helping us mitigate climate change. We're trying to help stop it at its root by diverting some of the energy that would be used from fossil fuels and instead, getting people to use solar energy instead. So that's the mitigative aspect, but it's also adaptive. Yeah, adaptive in the sense we're trying to help people adapt to the symptoms of climate change, because in the case of a severe weather event or what have you, people don't have access to power. They can get power from our system. And so I love that question because it's kind of thinking about the adaptive aspects of our system or other similar systems. Because if you think about it, another symptom of climate change, other than more severe and frequent extreme weather events, is the climates of certain areas is going to intensify. That's okay. I'm really going on, but that's actually why the name was switched a while back, a good while back, officially from global warming to climate change. Because yes, the globe is warming, but really what's happening is climates are changing. So more dry, arid, hot areas are probably going to become drier and hotter. Houston, which is humid and hot, is moving closer to a tropical, I think biome is technically the correct term. So we're going to be dealing with a lot hotter temperatures, and of course there's safety factors related to that, because being exposed to really high temperatures and humidity exacerbates heat, by the way, is not safe. It's not good. So we need to be finding ways to give people access to cool air or areas where they can cool off somehow, because that's just not safe. Urban, do you want to take this next
Yeah,
question?
yeah.
I
So,
spent so long on that one.
so exactly. So it will have the same capacity from what we've calculated, but again, the same capacity as the ones that we already have and like at the school itself. They actually have some outlets that are pretty outdated now. And so ours will just have outlets enough for, phones that people have like iPhones and USB-C cables and stuff and that type of thing. Because they're the ones that they currently have, some of the wiring is still pretty outdated for the most part. So, but yeah, it should have about the same capabilities as it, but again, it would be mobile. So if there's an area, you don't have to like walk up to leave it there and then have to keep an eye on it when you can just move the station itself with you. Again, it makes it easier, more like efficient for the most part. So yeah.
And this will be as a soft duck?
What's up?
And this will be as a soft duck? Or where do you plan on having this station?
Okay, so the whole idea is to have it primarily outside where the eating area is at, because that's where the sunlight's going to be. But after a certain point, we're going to have to restructure the idea, like not fully, but to the point where it's more applicable to students. So we could maybe have it outside for a bit, let it charge it, because again, it needs solar energy to charge up the battery. So once the battery is at a sufficient rate where it can charge phones by itself, then we can bring it inside and then let students, use it however they want or can or will. Ideally, what we would want to do is maybe, build more onto this, maybe have like some solar panels, kind of what they already have at the science technology building, but have those discharge batteries that we can physically move around. Again, that would have outlets similar to the ones already found. But again, it's all going to be powered through solar energy. But again, that's still being like very optimistic about it, and whole other issue with that. But again, just to answer your question, yes, it's about similar size, but it should charge, if not more, phones than the ones that are already there at the university.
Okay. Thanks, Erwin. I hope this works out well.
Thank you.
Hi guys. So I really appreciate the work that y'all are doing, putting into UHD and like worrying about like sustainability and climate change and everything. Because not a lot of people, I think that now it's becoming more prevalent to where people are taking notice and they're like, oh my gosh, like it's really a thing and we really have to like make changes now, quickly, immediately. And so I love that y'all are so like passionate. Like I can tell y'all are very passionate about the subject. I am too. I was wondering like what your majors are. I guess it's like not related, but like what are your majors? Like how did you learn to like to build this? You know what I'm like, is there a specific class that y'all took that helped with like learning how to build like solar systems? Because I'm very interested in like learning how to build it myself too.
Yeah, again, I sent out my email, so if you want to have like the
cool.
like the main basic understanding of it, feel free to email me. But as far as regards to like our majors, my major is biological and physical sciences, but I'm minoring in sustainability, and Riley can say her major.
I'm majoring in safety management, also minoring in sustaneability. And Urban, if you want to talk about where we learned this information.
So again, and to answer your question, and again, and to pretty much answer everybody's questions too, in case they have that same similar question or idea. Again, that's an important factor where you have to be pretty flexible and being able to learn new material. Again, this was something that was completely out realistically out of our scope of practice that we majoring in. But again, we did take some courses that helped us, and again, the same mentors that we acknowledged earlier, they were crucial in our development for this project as well. Again, not everything is done by ourselves, but
yeah, absolutely. The basic course where we learn like the foundation for this information was I think it was called Introduction to Renewable Energy, something along that lines, with Dr. Vasilios Joannis. And that was taken as a requirement of our minor. But there was no like step-by-step guide. We just kind of learned like the principles of photovoltaics, benefits and drawbacks of different renewable energy systems. So a lot of this was mentorship, individual research, like reading and just finding, and yeah, so it's always a process, isn't it, with research or projects like this?
Yeah, that's amazing. Congratulations. That's
you,
like
thank you.
amazing. I'm actually majoring in BPS and I just like declared my minor in sustainability as well. And I'm actually taking the renewable energy systems course during the summer. So, but I was just like, man, I wish there was a class that like hands-on taught us how to, you know, build something or, you know, solar, whatever, you know. So
Yeah.
I'm always asking people like, okay, what class is that? Like, I want to
Yeah.
know how to. That's
The funny
awesome.
part
I'm
about that
excited.
though, is that we actually took that class during the pandemic, so it was all fully online. So we actually didn't
Oh,
even have any hands-on experience when it comes to actually making it until we were, again, we did the math first to make sure everything was, you know, gonna work or theoretically work. And so
yeah.
when we built it, that was the first time us touching wiring, you know, first time us building solar panels.
Wow.
So we didn't have any previous experience before that. We only took the class, so we know like the core ideas,
Yeah.
you know, how it works. But once you come to actual application, that was after.
That's wild. Was it like really hard? Like the actual building process itself, like did you have a lot of like technical issues? Like where like, oh, it wasn't working?
Well, so if you want to continue asking like these type of questions, feel free to email me. That way we
Oh,
can
okay, okay.
people also ask like, you know, questions,
Yeah,
but
yeah.
at the same time, but again, there was again technical issues again because we didn't know how to work with wires. So that was a learning curve as well. Yeah, sorry to interrupt you in that aspect, but just I want to make sure we answer everybody's
Yeah,
question.
yeah, yeah. Okay, thank
Okay,
you.
who else has questions? Who else has a pressing question they need to have answered right at this moment? All right, that's what I thought.
I have a quick question.
Okay, go ahead. Go ahead.
So my question is, you talked about solar powered and wind powered. So
Uh-huh.
did you ever think about like hydropower since we're so close to the bayou and so much water?
Hydropower.
Like,
I don't think we explored that just because, you know, if you think about it, we are near the bayou and everything, but you know, I mean, it's not just engineering issues. A project like this, like there's administrative stuff too. There's, you know, bureaucracy that goes into it. So if we're doing everything on UHD, that kind of insulates us from the bureaucracy because then we can just, you know, talk to our mentors and be like, hey, can you talk to facilities? Hey, like, can we all meet and work this out? It's just so much easier to communicate with people and get things done because it's all just in-house. But like if we move to like the bayou or something, then we have to look at zoning, like where does UHD's property line end? Are we like moving into the city? Do we have to get permits from the city for that? And then to connect it, do we have to worry about, you know, so we didn't want to put too many moving parts on ourselves. So that's kind of why we tried to just keep it in-house. But I do love that idea. I would love to see something like that in the future. I think it would just take, for lack of better words, somebody at the top to kind of make that happen. You know, someone with some authority, not a couple undergrad students, you know?
Yeah, also add on to that, Louis, I mean, it's a great idea. We also got to keep in mind we had $1,000 budget. And so, you know, maybe a system like that, you know, in order to generate enough power, you know, I don't know what you want to actually power. You have to also, again, consider the fact that we're trying to make this as, you know, cost effective as possible. So that was, you know, big limiting factor too. That's why we couldn't be too, you know, thinking too, like, you know, too broadly in that sort of sense. They have to kind of like narrow it down and find something that, again, cost effective, tangible, and realistically be done.
all right, thank you very much.
If no one has any other questions, Evelyn, I'd love to get into your question a little bit more. I think you were asking about, you were asking something about our components, or maybe she left. I don't know. Yeah, I think she left.
Yeah.
All right, y'all. Do you have any other
questions?
questions?
No,
Go ahead.
I don't have any questions.
Oh, okay. All right.
No
I'm sorry,
questions,
you
but
have
great
a question?
presentation.
Oh, okay. You just,
Appreciate it.
Sorry.
it's okay. I was like, wait, do you have a question or not? Thank you. I think it might be time to start up another round.
Oh,
Oh,
yeah.
wait, no, we're at 3 already.
Yeah.
Wow,
All right,
okay.
y'all. So I guess we'll see you there at the
How did
main
that
So what do
happen?
we do? We go back to the main room, right?
Yeah, main room.
All right.
Wow, that was
All right,
fun.
thank you.
Thanks, guys. Bye. Is anyone still in here? We
Yeah,
got a
two
few
people.
people. They're
Um,
filtering. Oh my gosh, that went by so fast. What the heck?
No, I had to cut. Like, I don't want to be mean, but I was.
No,
'cause I
it's
was
okay.
looking at
No,
the time
it
and I was
sounded
like,
so mean though.
oh, I mean, this is like there is no like nice way to really say like hey, so like I don't want to beat around the bush either because I know other
No,
people may
I
have
know, yeah.
questions.
All right, okay, let's go back in the main session.
But yeah, all right. Good job.
Thank you. You did so good too. Okay, bye.
Oh.
Thank you for like mediating too, because
Oh
sometimes
no,
I
no,
need to shut
you're
the
fine.
hell up.
No, you're fine.
Okay, bye.
All right, bye.